Hello and welcome to this Python tutorial. Alright, so we are done adding the layers of our artificial neural network, and now what we're going to do is to compile the whole artificial neural network, that is, basically applying stochastic gradient descent on the whole artificial neural network. That's what compiling means, and that's what we're going to do with this single line of code that we're about to add. Alright, so let's add it. We are going to start by taking our classifier object, as we did when we added the different layers in the ANN. And now we're going to use another method, exactly as we did here with the add method, but this time it's not going to be the add method. You can guess what it's going to be. It's going to be the compile method. As simple as that. So we're going to add a dot here, and then compile, which is right here, pressing enter. All right. And now, of course, this compile method contains several parameters. So let's add some parentheses here. And so now I'm going to explain to you what those parameters are, and we'll add them one by one. All right, so let's check out the arguments by pressing here Command I. And here we go, we have some info about this compile method. And the informations we are interested in are, of course, the arguments. All right, so let's look at the first argument. The first argument is optimizer. So what is optimizer? Optimizer is simply the algorithm you want to use to find the optimal set of weights in the neural networks. Because we defined our neural networks that is built with the different layers, but the weights are still only initialized. So now we have to apply some sort of algorithm to, find the best weights that will make our neural network the most powerful. And so that's why in this compile method here we need to add an algorithm, and this algorithm is going to be nothing else than the stochastic gradient descent algorithm. And there are several types of stochastic gradient descent algorithm, and a very efficient one is called ADAM, and that's exactly what's going to be the input of this optimizer parameter. All right, so let's add it right now. Optimizer equals, and so now we need to add in quotes, ADAM. Here we go. Great, then comma, and now let's add the second parameter. So the second parameter is loss, and this corresponds to the loss function within the stochastic gradient descent algorithm, that is within the ADAM algorithm. Because if you go deeper into the mathematical details of stochastic gradient descent, you will see that it is based on a loss function that you need to optimize to find the optimal weights. And so that's what we have to specify right now. It's this loss function, and so I can give you some examples. You saw the loss function when you studied linear regression. Remember in Kyril's intuition tutorials, the loss function was the sum of the squared errors. That is the sum of the squared differences between the real value and the predicted value. Well, that was the loss function that we used to optimize the parameters of the regression model. And here that's exactly the same. We have some parameters. Those parameters are the weights in the neural network. And so we need to specify a loss function that we will then optimize through stochastic gradient descent to eventually find the optimal weights. And so what is going to be the loss function for the neural networks? Well, again, if you want to go deeper into the mathematical details of stochastic gradient descent, well, this loss function is going to be kind of the same as for logistic regression. Because when you take a simple neural network with only one neuron, which makes it a perceptron model, and if you use a sigmoid activation function for this perceptron, well, you obtain a logistic regression model. And then if you go deeper into the mathematical details of stochastic gradient descent for the logistic regression model, well, you will find out that the loss function is not the sum of squared errors like for linear regression, but is going to be a logarithmic function that is called the logarithmic loss. And so since the activation function for our output layer is nothing else than the sigmoid function, well, the loss function that we're going to use here to compile our ANN and on which our stochastic gradient descent ADAM algorithm is based on, well, the loss function used to compile our ANN here is going to be the logarithmic loss as well. And what is the name of this logarithmic loss function here? Well, if your dependent variable has a binary outcome, then this logarithmic loss function is called binary underscore cross entropy. And if your dependent variable has more than two outcomes, like 3 categories, then this logarithmic loss function is called categorical underscore cross entropy. Alright, so that's good to know, and now you know what to use, what to input here for the loss function in case you're working with a dependent variable that has more than 2 categories. But here we have a binary outcome, so we'll input here for the loss parameter, in quotes, binary underscore cross entropy. Alright, and then quotes. Great. Perfect. And now we need to add a third and final argument. It's this metrics argument here. So what is this metrics argument? Well, that's very simple. That is just a criterion that you choose to evaluate your model. And typically, we use the accuracy criterion that we already saw many times in this course. So basically what happens is that when the weights are updated after each observation or after each batch of many observations, the algorithm uses this accuracy criterion to improve the model's performance. You're going to see that when we fit the ANN to our training set, well, the accuracy is going to increase little by little until reaching a top accuracy. And that will happen because we choose here the accuracy metric. All right, so let's add this argument here. Metrics equals, and since actually this metrics argument is expecting a list of metrics, but here we only use one metric, which is the accuracy metric, we need to add this accuracy metric in brackets, because by adding these brackets like that, we are creating a list. But this list will only contain one element, which is the accuracy metric. All right, perfect. And now we're ready to compile the ANN. So let's do it. We will select this line and execute. All right, perfectly well compiled. Perfect. So that step is done. And actually the next step is the most exciting step of this whole section, because this is in this step that we're going to see the algorithm in action. We are going to choose a number of epochs. That is, the number of times we are training our ANN on the whole training set. And so we're going to see the stochastic gradient descent in action. That is, we're going to see how our ANN model is trained and how it is improving its accuracy at each round, that is, at each epoch. So that's going to be very exciting, and that will be the show of the next tutorial. Until then, enjoy deep learning!